Hello all, welcome back to another video. In this video, I'll be explaining about the solution of the fourth question. Design a full ladder by constructing the truth table and simplify the output equations. The full ladder consists of three input variables and let that variables be A, B and C. And the full ladder consists of two outputs, that is sum and carry. Since there are three variables, there will be 2 to the power of 3, 8 combinations of zeros and ones as input to the full ladder. And they are 0, 1, 2, 3, 4, 5, 6 and 7. The binary of 0 is 0, 0, 0. You can use the 4 to 1 trick here in order to write the binary number. For 1, the binary is 0, 0, 1. Binary of 2 is 0, 1, 0. Binary of 3 is 2 plus 1, 3. Remaining bit is 0. Binary of 4 is 1, 0, 0. Binary of 5 is 4 plus 1, 5. The remaining bit is 0. And binary of 6 is 4 plus 2, 6. The remaining bit is 0. And binary of 7 is 4 plus 2 plus 1, 7. Now you have to add these inputs. 0 plus 0 plus 0 will give you 0. Is there any carry? No. Therefore, the carry is 0. Again, 0 plus 0 plus 1 will give you the sum as 1. And is there any carry here? No. Therefore, the carry is 0. Again, 0 plus 1 plus 0 will give you 1. The carry, there is no carry here. Therefore, 0. 0 plus 1 is 1. 1 plus 1 is 0 with 1 carry. 1 plus 0 plus 0 is 1 with 0 carry. Again 1 plus 0 plus 1 is a 0 with 1 carry. 1 plus 1 is 0 with 1 carry. Again here 1 plus 1 plus 0 is 0 with 1 carry. And the last one, 1 plus 1 plus 1 is 1 with 1 carry. That is 1 plus 1 will give you 0 with 1 carry. Add a 1 to this so that you will get 1 with 1 carry. Now the next step is you have to plot the K-map in order to get a reduced Boolean expression or simplified Boolean expression of sum as well as carry. So first of all, let us draw the K-map for sum. Let us plot this K-map for sum. Since there are three variables, the three variable K-map consists of 8 cells and the variables are A, B, C. Therefore, this is B bar, C bar or 0, 0 you can write. This is B bar C, B, C and B, C bar. This is A bar and A. This is 0, 1, 2, 3, 4, 5, 6, 7. Now you have to place the ones in the cells corresponding to the output given as 1. So which are those cells? They are 1, 2, 4 and 7. 1, 2, 4 and 7. Here you cannot group because there is no adjacent cells with ones. Therefore, you have to encircle this individually. So you will get 4 terms from this. Which are those 4 terms? They are first one A bar B bar C plus A bar B C bar plus A B bar C bar plus ABC. This is A bar B C bar. This one is A bar B bar C. This term is A B C and this term is A B bar C bar. Now you have to simplify this term. Here a bar is common, therefore a bar into b bar c plus bc bar plus here a is common, take it outside, therefore you'll get a into b bar c bar plus bc. What is b bar c plus bc bar? B bar c plus bc bar is b XOR c. Therefore you can write this term as a bar into b XOR c plus a into, and b bar c bar plus bc is b XOR c the whole bar. Now consider b XOR c as x. If b XOR c is x, b XOR c the whole bar is x bar. Now you can write this term as a bar x plus a x bar. A bar x plus a x bar. What is a bar x plus a x bar? It is a XOR x. Now substitute back the value for x, that is a XOR b XOR c. A XOR b XOR c. Similarly, you have to find the simplified Boolean expression for carry. For carry, the output for 3, 5, 6 and 7 is 1. So place ones for these cells in the K-map. Let us plot the K-map for carry here. The K-map consists of 8 cells since 3 variables are there. This is a 3 variable K-map which consists of 8 cells. A, B, C are the variables. Now mark the variables here: B bar, C bar, B bar, C, B, C, B, C bar, A bar, A. 0, 1, 2, 3, 4, 5, 6, 7. Now you have to place the ones in the corresponding cells. Which are those? 1, that is 3, 5, 6 and 7. 3, 5, 6, 7. 3, 5, 6, 7. You have to place it here. After that, you have to group this. Grouping can be done with adjacent cells. If ones are in adjacent cells, you can group it to 1. Similarly, these cells can be grouped. These adjacent cells can be grouped, so that you will get 3 groups here. This is called as AB, this one BC, and this group AC. Therefore, carry is equal to BC plus AC plus AB. Now we have to draw the logic circuit of the full ladder. Sum is equal to A XOR B XOR C, and carry is BC plus AC plus AB. So let us draw a XOR gate and give A and B as the input, so that you will get A XOR B as the output. Now give this output to another XOR gate with a variable, another input C, so that you will get A XOR B XOR C. This is the sum. This is one output. Next output is carry is equal to BC plus AC plus AB. Give B and C as the input to a AND gate in order to get BC. Next term is AC. Give the input A and C to another AND gate to get the output AC. Next, A and B can be given as the input to another AND gate in order to get AB. Now join all these inputs and give this to a OR gate, so that you will get BC plus AC plus AB, which is equal to carry. So this is the logic circuit of full adder.
Here is the fifth question. Reduce the following function using K-map technique and implement using basic gates. F of ABCD is equal to pi of 4, 5, 6, 7, 8, 12, 13 plus pi d of 1, 15. The solution of this question will be explained in the next video. Thank you.